If you have ever tried to get across Metro Manila during rush hour or during a sudden tropical downpour, you already know the reality of the city. The roads lock up, the traffic comes to a standstill, and travel times become completely unpredictable. But if you look above the gridlock, you will see something entirely different. You will see trains moving. For decades, Metro Manila's rail system has given the city something the road network often cannot provide: separation. The trains are lifted above traffic, meaning they are not directly trapped inside the same gridlock, intersections, and flooded streets as cars, buses, and jeepneys. This layer of separation was the system's first major evolution. A 1976 to 1977 World Bank funded study initially suggested building a street level railway for the capital. However, planners quickly realized that if the trains were on the street, they would get stuck in the exact same chaotic intersections as the cars. So the plan was revised into an elevated system. Construction started in October 1981, and the first section of Line 1 opened to the public on December 1, 1984, becoming Southeast Asia's first light rail transit system. This was eventually followed by MRT3 over EDSA and the heavier capacity LRT2. If you pull up a map of Metro Manila today, the active urban rail network is essentially drawn in three bold strokes. The first stroke is LRT3, the north-south spine. It runs from Fernando Poe Jr. Station in the north all the way down to Dr. Santos in the south, cutting through some of the oldest and most crowded corridors of Metro Manila to link Quezon City, Caloocan, Manila, Pasay, and Parañaque. The second stroke is MRT3, the EDSA spine. This is perhaps the most infamous line. It curves along Metro Manila's busiest highway, EDSA, and serves as the main commuter conveyor belt through several of the capital's major business districts. The third stroke is LRT2, the east-west spine. Cutting directly across the other two lines, it stretches from Recto in the dense city center out to Antipolo in the east. It is a heavier, wider train line built specifically to move massive crowds from the eastern suburbs into the city's university and commercial belts. Together, these three lines form the current active rail backbone. But if you look closely at this map, you start to see exactly why the system still feels so inefficient and easily overwhelmed today. The core problem with Metro Manila's current railway is not just the age of the trains. It is a structural flaw. The network is incredibly thin. In urban planning, a highly efficient transit system relies on overlap and redundancy. If a train breaks down in Singapore, Tokyo, or London, the entire system does not collapse. Passengers simply walk to a different platform and hop on an intersecting line to reroute their trip. Metro Manila does not have that privilege. Because the network relies heavily on just three active lines, each existing corridor is essentially a single point of failure. If MRT3 halts operations, hundreds of thousands of passengers do not have a parallel train route nearby. They are pushed back directly onto the congested road network, which is essentially the trap the rail system was supposed to protect them from. To make matters worse, even where these three lines do meet, the connections are fragile. For a long time, the system was built as a string of isolated projects rather than a cohesive web. While the introduction of a unified contactless beep fare card has helped speed up ticketing, the physical transfers between the lines remain inefficient. Passengers switching lines often have to exit a station, walk through long, sometimes uncovered pathways or down to the street level and climb back up into another station. This bottleneck is currently magnified because the city's legacy ground-level commuter train, the PNR, has been completely suspended in Metro Manila. The government shut it down to clear the corridor for new construction, so right now, the city is squeezed tighter than ever, waiting for a future system rather than enjoying an efficient one today. This raises an obvious question. If the city desperately needs more rail, why is expansion so slow? One of the hardest parts of building a mega railway in a city like Metro Manila is not just engineering. It is delivery. Before you can lay a single track, the government has to legally acquire the land, relocate affected communities, and move massive underground utilities. For example, as of January 2026, land acquisition for the new Metro Manila subway was reported at a nearly 91%, allowing construction to move forward. But land acquisition for parts of the NSCR, especially the northern section, was reported at around 56%. When right-of-way acquisition stalls, construction stalls, and the public is left waiting. But if the government can push through these delivery bottlenecks, the future map of Metro Manila's transit completely changes the city. The next generation of rail is massive in scale, and it is designed to fix the exact inefficiencies plaguing the system today. First, replacing the suspended PNR line is the North-South Commuter Railway, or NSCR. This is a 147-kilometer railway linking Metro Manila to Pampanga in the north and Laguna in the south. Implemented by the Department of Transportation and PNR with support from the Japan International Cooperation Agency and the Asian Development Bank, it will feature airport express trains capable of reaching 160 kilometers per hour. It is projected to handle 1 million daily passengers by 2045, finally giving the region a high-capacity commuter backbone. Second is the Metro Manila subway. Currently under construction, this is a 33-kilometer, 17-station underground line that will finally give the Philippine capital its first true subway system. It creates a brand new north-to-south artery that is far more protected from surface congestion. And because it is being built in a highly active seismic zone, the project is being designed with strict earthquake safeguards. Add to this the MRT-7, a brand new elevated corridor pushing northeast into Quezon City and Bulacan, and the planned MRT-4 which will head east into Rizal to relieve the heavily congested Ortigas corridor. But drawing new lines on a map only works if you fix the transfer problem. That is the strategic value of the North Triangle Common Station. It is meant to properly connect LRT-1, MRT-3, MRT-7 while placing the area near a future Metro Manila subway connection. By turning awkward separate stations into a massive integrated transfer district, it creates a true network redundancy. It gives passengers the ability to easily hop between lines without walking out onto the street. When you zoom out and look at the entire timeline, a clear picture emerges. The inefficiencies of Metro Manila's rail today is the result of a thin, disconnected network forced to carry the weight of a rapidly growing mega city. But the future of the system is fundamentally different. By adding subways, high-capacity commuter lines, and proper transfer hubs, the city is finally building an interconnected web, one that reduces the heavy dependence on any single road or rail line and gives millions of people a better way to move.